Welcome back to Database Internal's Crashcasts. I'm Sheila, and as always, I'm here with my co-host, Victor. Before we dive in, I want to remind our listeners that if you're enjoying our show, please rate us on your podcast platform. It really helps us reach more database enthusiasts like you.
That's right, Sheila. Your support means the world to us. Now let's get into today's topic. We're continuing our chapter on database architecture, and we'll be discussing the client-server model.
Excellent. But before we start, I have a quiz question for our listeners. What popular web application, launched in 2004, is a prime example of the client-server model and has over 2 billion monthly active users?
Ooh, that's an intriguing question, Sheila. It really makes you think about the applications we use every day without realizing the architecture behind them. I'm sure our listeners are racking their brains right now, trying to figure out which widely used application it could be. It's fascinating how something so technical is actually part of our daily lives.
Indeed, Victor. Now, before we dive deeper, could you give us a brief explanation of what we mean by client and server in this context?
Certainly. In the client-server model, the client is typically an application or device that requests services or resources. The server, on the other hand, is a powerful computer or system that provides those services or resources. It's a bit like a restaurant scenario. The clients are the customers placing orders, and the server is the kitchen fulfilling those orders.
That's a great analogy. So, if I understand correctly, in a database context, the client might be an application that needs to store or retrieve data, and the server would be the database system itself.
Exactly right, Sheila. You've got the basic concept down. Now let's delve a bit deeper. In the client-server model, communication happens through a request-response pattern. The client sends a request to the server, and the server processes that request and sends back a response.
Interesting. Are there different types of clients in this model?
Yes, there are. We generally categorize clients as either thin or thick clients. A thin client, like a web browser, relies heavily on the server for processing and data storage. A thick client, on the other hand, can perform significant processing on its own and might only rely on the server for data storage or specialized tasks.
That makes sense. So, what are some advantages of the client-server model compared to the other architectures we've discussed, like single-tier or two-tier?
Great question. The client-server model offers several advantages. First, it allows for better resource allocation. The server can be a powerful machine handling multiple clients, while the clients can be less powerful devices. It also provides centralized data storage and management, making it easier to maintain data consistency and security. Additionally, it's more scalable than single-tier architectures, as you can upgrade the server or add more servers without having to change the clients.
Those sound like significant benefits, but surely there must be some challenges or disadvantages as well.
You're absolutely right, Sheila. One major challenge is that the server can become a bottleneck if too many clients are making requests simultaneously. There's also the issue of single point of failure. If the server goes down, all clients lose access. And implementing a client-server system can be more complex than a single-tier system, requiring careful consideration of network protocols and security measures.
I see. It seems like there's a lot to consider when implementing a client-server model. Are there any common misconceptions or pitfalls that developers should be aware of?
Definitely. One common misconception is that the client-server model always involves a web browser as the client. While that's a common scenario, client-server architectures can exist in many forms, including desktop applications, or even between different services in a microservices architecture. A common pitfall is underestimating the importance of proper error handling and recovery mechanisms. In a distributed system like client-server, network issues or server downtime can occur, and the client needs to be able to handle these gracefully.
That's really helpful, Victor. Can you give us an example of a real-world implementation of the client-server model in database systems?
Certainly. A great example is MySQL. When you use a MySQL database, your application acts as the client, sending SQL queries to the MySQL server. The server processes these queries, accesses the data stored on disk, and sends the results back to your application. This separation allows multiple applications to interact with the same database server, providing a centralized data store for your entire system.
That's a clear example, thank you. Now, I'm curious about how the client-server model compares to more modern architectures like microservices. Any thoughts on that?
That's an excellent question, Sheila. The client-server model and microservices architecture aren't mutually exclusive. In fact, microservices often implement client-server relationships between different services. The main difference is that in a traditional client-server model, you might have a monolithic server handling all types of requests, while in a microservices architecture, you'd have multiple specialized services, each handling specific types of requests. This can provide better scalability and flexibility, but at the cost of increased complexity in system design and management.
I see, so it's not so much about replacing the client-server model as it is about evolving and adapting it. Before we wrap up, do you have any tips or best practices for implementing a client-server model in database systems?
Absolutely. Here are a few key points to remember. 1. Design your API carefully. It's the contract between your client and server. Point 2. Implement proper authentication and authorization to ensure data security. Point 3. Use connection pooling to manage database connections efficiently. Point 4. Consider caching frequently accessed data on the client side to reduce server load. Point 5. Always validate and sanitize data on both the client and server sides to prevent security vulnerabilities. Remember, the goal is to balance the workload between client and server effectively while maintaining security and performance.
Those are great tips, Victor. Now, I think it's time to reveal the answer to our quiz question. The popular web application launched in 2004 that's a prime example of the client-server model and has over 2 billion monthly active users is Facebook. When you use Facebook, your web browser or mobile app acts as the client, constantly sending requests to Facebook's servers for updates, posts, messages, and more.
Excellent reveal, Sheila. It's amazing to think about the massive scale of Facebook's client-server architecture, handling billions of requests every day from users all around the world.
Indeed it is. Now, let's summarize the main points we've covered today. Point 1. The client-server model involves clients requesting services from a centralized server. Point 2. It offers benefits like centralized data management, scalability, and resource allocation. 3. Challenges include potential bottlenecks and single points of failure. 4. Real-world implementations include systems like MySQL. 5. The model continues to be relevant even in modern architectures like microservices. Thank you all for listening. If you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, keep diving into the fascinating world of databases.